So this video, we're going to go ahead and take a look and recall the derivatives of trigonometric functions. The derivatives of trigonometric functions. Trigonometric functions. You see, life couldn't be easier. We couldn't have calculus without dealing with trig functions. So you do have to, in order to pass the AP test, you do have to know every single one of these derivatives. You have to know that the derivative of sine of x is cosine of x. You have to know that the derivative of cosine is negative sine. You've got to know tangent. You've got to know, so we've covered these two. You've got to know that the derivative of tangent is equal to secant squared x. You have to remember that cosecant of x is equal to the derivative of cosecant is negative cosecant cotangent. You gotta know that. You've got to know that secant is the derivative of secant is secant tangent, and you've got to remember that the derivative of cotangent is negative cosecant squared. So you've got to remember your derivatives of trigonometric functions. On the AP test, you will have to memorize them. So I'm gonna make a little note for you guys. You need to memorize these. Make Quizlets, do flashcards on index cards, but however you do to learn these, you have to memorize them for basically all of calculus. This is pretty fundamental stuff. You've got to know this. And so I'm just going to do it from now on. I'm just going to do, I got two more practice problems in this video that I'm just going to move on to the practice problems and just maybe take a screenshot of it, and so that you can save these for later on and just know how to just remember your derivatives of trigonometric functions. So without that, let's go with that out of the way. Let's go ahead and move on to our first example. And the first example is find the derivative of y with respect to x when y is equal to the sine of x times the cosine of 2x. Now, right away, I noticed that we have a product rule. We've got the first times the derivative of the second. So right away, when I start doing y prime, my first thought is product rule. So we're going to do the first, which is sine of x, times the derivative of the second. Well, again, this is a chain rule because I've got a linear function. Let's see, I'll do pink and purple for this. I've got a linear function within a trigonometric function. So when I go ahead and go to multiply these, I'm going to have to do the chain rule. So again, we're going to peel our onion. The outermost layer is cosine. The derivative of cosine is negative sine. The inside is going to remain unchanged, so we'll keep that as 2x. And then we'll go ahead and cap this off. And then we're going to want to multiply by the derivative of the inside, and that's just 2. So I'm going to get rid of all this since it's just 2, and I'm going to add the negative 2 out front. And then write that derivative of cosine is negative sine. And again, the inside of 2x remains unchanged. Go ahead and cap off all these parentheses that we've decided to include here. Then we're going to add it. I guess we're writing in red the answer. So we're going to add it to the second, which is cosine of 2x, times the derivative of the first. And the derivative of sine x, that's simply just cosine. That's simply just, oh my gosh, I cannot write today. That is simply just the cosine of x. So now we've done all the calculus. We've got the calculus out of the way. Let's go ahead and wrap up the algebra. So I'm going to see that we're going to get a negative 2 times, well, a sine times a sine is a sine squared, times the sine squared. Well, actually, we can't really do that because this is sine x, this is sine 2x. So we're just going to get negative 2 times the sine of x times the sine of 2x. And we're going to add that to the cosine of x times the cosine of 2x. I'm going to have to mark all of that right there. And so finally, I can state this as y prime equals the cosine of x times the cosine of 2x times cosine of 2x minus 2 times the sine of x times the sine of 2x. That is the derivative that they were asking us to find. So let's go ahead and do one more example problem. We're going to find the derivative of the sine of cosine of 2x. So here's the thing: is this time I get not only we got an outside function. I don't have an inside. I have a middle function, and then I have an inside function after that. There's 3 functions stacked up in here. On the very inside, the very center, I've got a linear function. Then I've got a trig function outside of that, and a trig function outside of the trig function. So we have a three-decker chain rule, which we haven't seen yet on this channel. But I can tell you that if you got a 3-decker or more chain rule, you can simply just do the same procedure over and over again. So we're still going to take each layer and work our way in without changing what's in the inside. So we'll start with the very outside. The derivative of sine of x is cosine of x. But we're going to leave the inside unchanged. So we're going to leave not only this cosine unchanged, but the 2x as well. All of it is going to remain unchanged. This is all going to be the same. We're then going to multiply. By the derivative of the inside. But the derivative of the inside is another chain rule, and we're going to times the derivative of the middle. So the derivative of the middle, the derivative of cosine of x, that's simply negative sine of x. So we're going to multiply by negative sine, but again, the inside is going to remain unchanged. So we'll keep the 2x on the inside. And then finally, we're going to multiply by the very, very, very inside, and the derivative of a linear function 2x, that is simply just 2. So now we can go ahead and we've done the calculus. We can do all of the simplifications. And so I'm going to get that, well, a cosine x times a cosine 2x. So very simply, this is going to end up being 2 times, I guess it's going to end up being negative 2 times the sine of 2x times the cosine of, I did not mean to write, actually, I see why I was confusing myself here is because I wrote this cosine of x, but I think because I was saying the derivative of sine of x is cosine of x, but there really isn't an x there. So for those of you that were being confused, I am so sorry. There should not have been an x there at all. I'll make this look all a little more like it's, with the function and all. My bad. But so I think that's probably why I was confused. I was like, wait, can't I just combine these? But no, I can't. So then we're going to get the cosine times the cosine of 2x. That is the derivative that we were asked to find. That right there is the correct answer. And those are a couple examples involving trigonometric functions and finding the derivatives of trigonometric functions.